Okay, let's consider this problem. This problem is the kinematics problem of the particle, and the problem is the particle move along a horizontal path with a velocity of uh, defined by this function. The velocity function is defined by this. V is equal to 3t square minus 60 meter per second. And if it initially located at the origin point O, this is a point O, okay, and determine the distance. We have the distance travel in 3.5 seconds. And the second question is the particle average velocity and average speed. Okay, so we have three questions. That is, the first one is the distance, the second one is the average velocity, okay, and the third one is the average speed. Okay, so and each value we have to determine during the time interval, that is in 3.5 seconds. Okay, so let's consider we have to starting with we know that the kinematics of the particle, the velocity is equal to ds by dt. Okay, so according to this, we found that if we would like to find the displacement or distance, we have to integrate ds equal to integrate v dt. Okay, so according to this, we already know that from this problem, we know that the velocity function is equal to 3t squared minus 6t, right? Okay, and according to this, so we can find the displacement function, that is according to integrate ds equal to integrate v dt, right? So according to this, we can find the displacement function s equal to integrate 3t squared minus 6t dt, right? And then, oh sorry, and then as we integrate the polynomial function like this, we found that it's equal to 3 cubed minus 3t squared. And don't forget to plus the constant, that is constant c, okay? So, and according to this, according to the initial condition, come back to see the initial condition. If it's initially located at the origin O, okay? So at the origin O, it means that we may, the initial condition is what? Initial condition is when time equal to 0, okay? When time equal to 0 second, s is equal to 0 meter also. This is at the initial point. So according to this, when we substitute time equal to 0 into this, when t equal to 0 into this, okay, we get s equal to 0, okay, according to the initial condition when time equal to 0. So it means that we substitute time equal to 0 into this equation, so it's equal to 0 plus c. What does it mean? It means that the constant c is equal to 0, right? Okay, so then we will obtain S equal to t cubed minus 3t squared. Okay, this is the displacement function. Okay, so this is the displacement function, not distance. And the displacement, we know that it is the vector quantity, right? Okay, it is a vector. So that is it means it is the shortest distance in the interval time. Okay, so but this problem we have to find the distance. Okay, the distance that the particle travel in 3.5 seconds. In 3.5 seconds. So then, according to this equation that is define the velocity function, define the velocity. So, it is the parabolic function. It is the parabolic function. So we would like we should determine which time that is the velocity each change the sign. Okay, so according to this, so we should find that which time that the velocity is equal to zero, which time that velocity is equal to zero. So when then we will determine that when time equal to what and velocity is equal to zero. So according to this, we found that if we set up velocity equal to zero, so we solve this equation. We found that it should be the equation, it should be 3t rate and equal to t minus 2. Okay, equal to 0. So that means that t equal to 0 and t equal to 2 seconds, right? Okay, and when t equal to 0, we know that it is the initial condition. And so right now we found that t equal to 2 seconds, the velocity is 0 again. The velocity is come to 0 meter per second again. Okay, so according to this, we will find the distance. Okay, so according to this, it means that the displacement, that is the, is maybe not positive, just only positive, just it means that is the particle is not go to the same direction. Okay, so if we consider for time interval is just greater than 0, but it's not greater than 2 seconds. Okay, it's just in periods of 0 to 2 seconds. It means that the velocity is negative. And the particle move to the left. Okay, the particle should move to the left. Okay, so we will see that at time t equal to 2 seconds, what happened? Substitute time into the displacement function. We get S is equal to Q minus 3 times 2 square. Okay, and then we get it equal to minus 4 meter. Okay, so this means that it's go to the left because we from this it should the positive one is go to the right? So it means that when time equal to 0 second, it's starting at this point. And after when time equal to 2 seconds, the particle is moving to here. Particle is moving to here. And it's equal to 4 meter. Okay. And after that, the velocity is become 0 again. So it will change the direction of the motion. It will change the directions of the motion. And after that, when time t equal to 3.5 seconds, when time t equal to 3.5 seconds, what happened? So S is equal to 3.5 power 3, okay, minus, sorry, minus 3.5 square, okay, and then get that S is equal to 6.125. This is positive one, right? Meter. So it means that it's moving to the right. Okay. So the position is to the right. Okay. So it means that when at time equal to 3.5 seconds, the particle is on the right hand side of the starting point. Okay, so it's moving to this point. Okay, with (6.125 meter). Okay, so according to this, so it means that if we would like to find the distance, in 3.5 seconds is what? Distance. I use the notation ST, that is mean is total. The total of distance is equal to 4, right? Because it's starting, if you draw the picture, you will see that it's moving at the 2 seconds. At 2 seconds, it has 4 meter first. And after that, it's come back with, have to come back with 4 meter again. Okay. And then it's go to the right with 6.125 meter. So the distance is become 4 plus 6.125. It's become 14.125 meter. Okay. So this is the answer of the first question. Then we move to the velocity. For the velocity, average velocity, the average velocity is determined from delta S by delta T. But delta S, that is mean that it's just only this, because this is the final position. This is the final position. This is the initial position. Okay, so the distance, the displacement is measured between the final position and the initial position. This means that it is equal to 6.125 meter. Okay, and the time interval, that is 3.5 minus 0, right? So the average velocity is become 1.75 meter per second. Okay, this is the second solution. But if we finding the average speed, okay, so for the speed, average speed is determined by using the distance. That is, we have to use the st, that is the distance, okay, divided by delta t, that is equal to 14.125 divided by delta t, that is 3.5 minus 0, right? So it's become 4.036 meter per second. That is the answer. Okay, so that's all for this problem.